Welcome to the lecture series of Embedded Controller. We are seeing the PIC microcontroller. So today we are going to see the concept of time delay. So how to produce a delay in your microcontroller. So there are, as already discussed, there are two ways to create a time delay in C18 programming. So using for loop and the inbuilt peripheral called timers. So using for loop is an simplest method and it is a trial and error method. So we cannot measure the time delay exactly. So how far if the loop runs, it will produce 1 millisecond delay. So likewise, we have to get some trial and error loop concept and we have to apply by means of oscillating measuring thing. So another thing is pick 18 timers. So it is used to measure use oscilloscope to measure the duration of our time delay. So normally two factors that will affect the accuracy of time delay. One is crystal frequency that is connected to oscillator 1 and 2 input pins. It is the most important factor in the time delay calculation. So the duration of the clock period for the instruction cycle is a function of this crystal frequency. So for in order to execute the one instruction, how many cycles it will take, how many clock pulses it will generate. So that is the thing. So the second factor is time delay in C program. So the compiler is used to compile the C program, whatever the user is giving, and the assembly language will convert the instructions and it will run according to the sequences used in a delay subroutine. And C program compiler convert into assembly. As a result, different compiler produce different hex code. So it is very difficult to calculate time delay using C. So uses the oscilloscope to measure the exact duration. So that is, we'll take an example. Write a C18 program. Sorry, write a C18 program to toggle all the bits of port B continuously with a 250 milliseconds delay. So toggle in the sense if my bit is 0, then you have to change it as a 1. So similarly, if it is 1, then you have to make it as a 0. So assume that the system is PIC 18F and your crystal frequency is 10 megahertz. So let us look into the program. So here this for loop. This is the for loop which will produce the delay. So if for I equal to 0 and I less than I time, this is an delay what we need to produce. So and I plus plus and inside again one more for loop require j equal to 0, j 165 and j plus plus. So how it will run? The first loop runs for I equal to 0 and I less than I time means my delay comes here as 250. So the 250 value is come into I time. So the condition is true. Now it gets into for loop j equal to 0 and j 165 the condition is true and it will increment the j. So now j moves to 1, again the condition true, increment goes on. So this loop will run up to the condition for 166, for j value 166. So that is this loop will run 165 times for first value of this for loop. So similarly, if it runs like this for my first value of I and the j loop will run up to 165 times, this particular loop will produce a delay of 1 milliseconds. That is 1 milliseconds delay. So this for loop will produce 1 millisecond delay if it runs once. For example, if I am going to make a 250 milliseconds delay, then I have to feed the 250 value automatically here. So if this I is running only one time and this j value runs 165 times, then it will create 1 millisecond delay. So in order to create 250 milliseconds delay, I have to feed the 250 in your I loop. So that is the condition. So using this function, I can create a delay in my program. So this is just a PIC 18 program. So just I am assigning the port B port B as 0, port B as output. So I am making the tris B as 0 so that it will make a port B an output. And in order to repeat the loop forever, I am going for while. So while of 1, it will repeat the sequence again and again. So just I am sending the port B value as 1. What is the value of this hexadecimal? This hexadecimal value represents 0x55, that is 0, 1, 0, 1. This is for first 5, and again 0, 1, 0, 1. So this is your 5, 5. So the port B of 8 bits will feed into these bit values. And again, what is AA? So that is 1, 0, 1, 0. This is for first A. Similarly, 1, 0, 1, 0. So these 8 bits will feed into the port B again after 250 milliseconds. So the bits automatically, see, when you compare these two, the bits automatically gets toggled 0, 1, 1, 0, 0, 1, 1, 0. So the bits automatically gets toggled. So all the bits of pins of port B now gets toggled with a delay of 250 milliseconds. So now think over, if my delay is 500, then what I have to change here? So if this loop runs one time, then the delay will, this loop will run one time and J loop will run 165 times, then my delay will be 1 milliseconds. So if I want to change, if I want to create 250, so this 250 will be added here. So if I want to increase the delay from 250 to 500, what I have to do? I have to change instead of 250, I have to mention it as 500. So now the 500 millisecond delay is easily created in my program. So in this way, we can create the time delay in using PIC microcontroller programming. So next, write a C18 program to toggle all the bits of port C and port A continuously with a 250 millisecond delay. So just indicating 0x55, 0xDD in port C and D, and similarly after 250 milliseconds delay. So initialization, that is toggling. So you are feeding the values to put C and D as 0xAA. So C and D as now your input, is your output. So making C and D as 0. So the delay is written here as a function. This is a very simple program. And the next concept is ibargo programming. So in case of PIC microcontroller, both byte size and bit size at the programming is also possible. So far in the different examples we have seen, all the bits are configured in port B. So far I am sending the values. So I am sending the values as 0x and 0x55 and 0xAA into my um, port B, port C, and port D. Now, if I want to feed only one bit, that is that is seventh pin of port B, or sixth pin of port C, or fourth pin of port D. So what I have to do, I have to make it as a bit addressable programming. So I have to configure that bit alone without disturbing other bits. So I want to configure that is RB7 alone, R and B 7. So seventh pin, that is eighth pin alone I have to configure. I don't want to disturb other pins. So that is called as bit addressable programming. That is also possible. So all the ports in PIC starting from port A to port E are byte accessible, and there are labeled here. So let us take one example. LEDs are connected to the bits in port B and port C. Now C18 program that shows the count 0f of 2 LEDs. You just make a try here, and this is a write a C18 program to get a byte of data from port B, wait half second and then send it to port C. This is another example to get the byte of data. Just assign the values to port B and make a delay of half second, in the sense 500 milliseconds. So then the same value need to be sent to port C. You just make a try. And again another program to get a byte of data from port C. If it is less than 100, then send to port B. And if otherwise greater than 100, you have to send to port D. So you have to give if else condition after that port C. So next is bit addressable. Let us check one by one. So starting from port A to port E. So port A can be each bit represented as RA0, RA1, RA2 up to RA5. Port B also RB0 to RB7. So if I want to configure only the bit, this bit can be represented as equal to 0. If I am assigning, then the particular bit alone will feed into the input 0. Or if I am making it as 1, then this particular bit also can be termed as 1. Similarly, all other ports are also bit configurable. So this is an example, just a C18 program to toggle only one bit or before continuously without disturbing the rest of the bits. So just configure. So tris B4 alone, you are making it as an output. So just representing as 0, and you are making the variable as my bit. So now in order to turn on the LED connected at that RB4, so you just provide a value of 1, so it will turn on the bit 4, and if you again put 0, then it will turn off the bit 4. So this is the one of the best examples of providing the bitwise representation. So similarly other examples are there. You just go through everything. Hope you understood.